All right, I'm continuing with going over problems from worksheet 2. All right, we're on number 5 now. Winning the jackpot in the Florida Lotto requires that you choose 6 different numbers from 1 to 53, and your numbers must match the same size numbers that are later drawn. The order of the selected numbers does not matter, right? If you buy one ticket, what is the probability of winning the jackpot? All right. And so remember, you're going to have 6 numbers that you're choosing 1, 2, 3, 4, 5, 6. And all of those numbers are between 1 and 53. Right. So say you have a big, container of numbers, right? 1, 2, 3, 4, all the way up to 53. And what you're going to do is basically choose those numbers one by one without replacement, and then they're going to be the numbers that are chosen for the jackpot. And if you match all 6 numbers in any order, because the order does not matter, then you get the jackpot. Okay? And so remember that our classical probability is probability of A is the number of ways A can occur. Divided by the total sample space. All right. And so the number of ways that A can occur, well, let's talk about our total sample space. So our total number in our sample space, number of events in our sample space, right? That is the part that has the counting elements in it, right? And the counting elements comes from the context of these 6 numbers, choosing those 6 numbers when they're from 1 to 53 without replacement, and they can be in any order. Remember, when order does not matter, that means 1, 2, 3, 4, 5, 6 is the exact same thing as 6, 5, 4, 3, 2, 1, right? When that happens, we use combinations. We don't count those 2 things separately. And so I know I'm going to have a combination. And since we're picking some of these numbers out of these numbers here, right? We're going to choose some of the numbers out of this larger set of numbers. We're going to use our combinations 53. There's 53 total, and we're choosing 6. And because the order doesn't matter, meaning 1, 2, 3, 4, 5, 6, and 6, 5, 4, 3, 2, 1 are the exact same thing. That is why we use combinations. All right. With that, there is only one of these that will match the exact 6 numbers that we pick, right? Because these don't count things that have the exact same numbers separately. They all count one time. And so only one out of those is going to give us the actual jackpot. And so our probability of getting the jackpot or winning the jackpot is 1 out of 53 choose 6, which is 22,957,480. And you can put that in your calculator to get the actual decimal. Number 6. Credit card numbers typically have 16 digits, but not all of them are random. Answer the following and express probabilities as fractions. Part A. What is the probability of randomly generating 16 digits and getting your MasterCard number? So if you had a MasterCard number, what is the probability if someone wanted to take your account number or your card number, what's the probability that they can do that, right? Now there are 16 numbers, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is a type of problem that's different from the last problem, right? In the last problem, we had a set of numbers from 1 to 53 in a big pool of numbers, right? And we selected them one by one, right? And we selected them without replacement. In this case, we're not in that type of situation. We have digits from 0 to 9, right? That's 10 digits, right? And basically what can happen, this first digit can be one of those 10s, of those 10 digits from 0 to 9. The second one can be from 0 to 9. That third one can be from 0 to 9. All of these can be a digit from 0 to 9, right? If we're randomly generating them, right? And so the number of arrangements or if you want to think about your sample space, is 10 times 10, 16 times, or 10 to the 16th, right? And so if I want to know the probability of randomly generating the 16 digits of my specific MasterCard, well, there's only one arrangement that I can have, and it'll be over 10 to the 16th. Right? And so my answer here will be 1 over 10 to the 16th. Notice it didn't say that we were going to choose one of the digits and then like replace it or not replace it and then be able to choose another digit, right? If that were the case, then I would do 10 times 9 times 8. If I could only use one digit or the digits could not repeat, then I would be in the case of a factorial. And so I would use 10 times 9 times 8. But that doesn't make sense because we have 16 total digits anyway. So I couldn't kind of ask you that, given that our credit cards have 16 digits. All right, let's go to part B. Receipts often show the last 4 digits of a credit card number. If those last 4 digits are known, what is the probability of randomly generating the other digits of your MasterCard? And so the only difference here is instead of having 16, we already know that the last 4 are like 1, 2, 3, 4, but we still don't know the other 12, right? I think that's 12, right? And so the only difference here is our probability or our sample space is a lot smaller because these are already set. We already know these. These are the ones that we randomly generate. And so since we're randomly generating them, and they're a digit from 0 to 9, then I get 10 to the 12th as the probability. All right. I hope this video was helpful in reviewing concepts in probability. Remember, when you're preparing for this exam, look at the old quizzes, the old worksheets, and the review problems in your book that I posted on D2L, right? All of these things should be reviewed for you to be successful on this next test. All right, good luck as you study. If you need anything, just send me an email.